So hi there, this is my new video about Thevenin's theorem. It took me quite a while to record this, but I did it with example and I hope you all understand it. So, the complex linear circuits we are looking at, this means circuits with resistance and voltage sources and current sources. And these can be easily replaced by a circuit looking like this. This is Thevenin's simple circuit with the voltage source and resistance. And you have the two poles A and B, and you have a Thevenin voltage, U Thevenin, like you see, between these poles A and B, and you have a resistance R Thevenin here, and that's all you can have to replace a quite complex circuit. And we draw one now as an example. Let's do a voltage source with, let's say, 9 volt, because everyone gets a 9 volt battery in his drawer. And then a kilo ohm of a resistor, then another kilo ohm or 2 of a resistor. Then a 1.5 volt battery against the 9 volt battery. And just for fun, we draw the R3 with 1 kilo ohm, another resistor, in parallel to the 9 volt battery. Now let us convert this circuit to a Thevenin equivalent circuit. And how we do this. So first, what the others don't tell you, mostly you are free to choose where you want to draw your poles A and B, for which you want to calculate the replacement, the Thevenin's replacement. I randomly choose A here and B there, above R1 and below R1, A and B. And there we want to calculate our U Thevenin. So of the replacement, this whole thing will be replaced by our Thevenin circuit. So one strategy to get this voltage, you just get it like calculating any linear circuit, the voltage at this place between A and B. And therefore my idea is now to calculate the current that is flowing through R1, which I call big red I. Let's find this current. And the idea is here to calculate the outer loop. And the voltage drops out here, so the voltage drop of 9 volt minus drop of R1 minus drop of R2 minus this 1.5 volt voltage source against it, they all sum up to 0. This is Kirchhoff's voltage law. And so we just do some calculus, 9 volt and 1.5 volt together, then I to the other side, divide by R1 plus R2. You can all stop the video and this all makes sense, I hope. And we get to, the current is 3.75 milliampere. And with this voltage we can now find U Thevenin. We say U Thevenin is R1 times the voltage, and it's 1 kilo ohm times the 3.75 milliamps. And therefore U Thevenin is 3.75 volt. So we have found our voltage for the Thevenin replacement circuit. That is to be drawn like this. So if we make a replacement of our complex circuit with a more simple Thevenin circuit, we have here this battery source here to the left has to have 3.75 volts as a constant voltage source. Now we have to calculate R Thevenin. And there, for this, there is a really nice way to do that. First, we short out all voltage sources. Sounds a little strange, but that's it. Let's erase them, the voltage sources, and then just draw straight lines over it. And I tell you, and the second thing is to do the current sources removal, but we do not have any current sources. And so now we calculate resistance between A and B, and if you look closely to it, it's simply R1 and R2 in parallel. R3 really doesn't matter because the current will never go through it. It will always go the upper way because there is a short. That's a little tricky here. And so if we do this simple parallel calculations of 2 kilo ohm resistors in parallel, we land at 500 ohms. And now we have R Thevenin, previously we had U Thevenin, and now we have everything together. We can replace our complex circuit by this one, having 3.75 volts as a battery or a voltage source and 500 ohms as a resistance. And that's it. Neat, isn't it? I hope you like this video. Please like and subscribe. Bye.